Hello guys, it's so good to have you again. Right. In today's video, we have our fifth question in our series. And it's a question that we are going to be making use of the integration approach called integration by partial fraction to solve. Right. So we have the rational function and we want to integrate this function such that we'll be able to get the integral of this function. So I will be making use of our knowledge of partial fractions, and then by the time we are done, right, making our rational functions partial, then we now apply our integral. So let's get straight into it. All right, so we have integral of 5x minus 3 upon x squared minus 5x plus 6 dx. So what do we do? The first thing we have to do is that we try to break this down into simpler fractions. Now, the idea about partial fraction is you have a number, say 3 over 4, and then I'm trying to tell you that, all right, so I can break 3 over 4 down to say maybe 1 over 2 plus say 1 over 4, right? So if we do 1 over 2, add 1 over 4, this automatically gives me 3 over 4. So the idea is I want to break a big fraction into simpler possible units. So that is the idea that we are going to be making use of here. So let's work with that, and let's see how far we can go to achieve that. All right, so we have this. So I'm going to pick 5x minus 3 over x squared minus 5x plus 6. Now, you see, anytime we want to solve something related to, anytime we want to solve partial fraction questions, right, the first thing you have to check is your denominator, right, factorizable? So you want to check, is it factorizable or not? Because the approach we use to solve those that are factorizable is quite different from those we used to solve non-factorizable denominator. So I want you to look at our denominator and we are going to check if that is factorizable. So of course, if we factorize this denominator, we are going to be having x minus 2 and x minus 3. So of course, that means we have a factorizable denominator. So there are many approaches we can use to solve partial fraction questions. We have the cover-up rule, we have the comparison method. So, but I'm going to be using the cover-up rule. So I'm going to do something like this. So 5x minus 3 over x minus 2 and x minus 3. So I'm going to do something a over the first value, that is x minus 2, then plus b over x minus 3. Now you might wonder, why do I just have just two fractions written on the right hand side? The reason is because at the denominator, I only have two values. You can see this. So and that is why I'm just having two. If I have three, it becomes three in that order, right? So and be very, very mindful. You see that in this case, I do not have a repeated root. So you see, the roots are different. By the time I solve this, I'm going to get 2 and 3, very different roots. When we have repeated roots, the approach to solve them also becomes a little bit different. Please, let's take note of that, right? So the next thing I want to do is this. I'm going to just multiply through, right? I'm going to multiply through by x minus 2 and x minus 3. So by the time I do that multiplication, we know that all of this will be cancelled by this. So I'm going to be left with 5x minus 3 equals the x minus 2. We cancel this x minus 2, and I'm going to be left with x minus 3. And the x minus 3 here, we cancel the x minus 3, and I'm going to be left with x minus 2. So the main issue now is that we need to solve for A and B. So how do you do that? So you come to where you have under A, you have x minus 2. So I'm going to say, let x minus 2 equals to 0. So I'm trying to find this root. So I'm getting x equals to 2. Then I pick x equals 2 and substitute it back into this. So I'm just going to go this star. So we have 5 into 2 minus 3 equals A into 2 minus 3 plus B into 2 minus 2. 5 multiplied by 2 rather is 10, and 10 minus 3 is going to give us 7, right? Now, 2 minus 3 is minus 1. Minus 1 times a is minus a. 2 minus 2, of course, is 0. 0 multiplied by b gives us 0. And by the time we do minus a plus 0, we get 0. So I'm just going to multiply both sides by minus 1, right? So that I now get that my a is 7. All right. So to get the value of b, I'm going to do the same thing. And I'm just going to say set x minus 3 also equals to 0. And that tells me that x equals to 3. So I'm going to take this value as well and then substitute it inside star, this same expression. So we have 5 into 3 minus 2 equals a into 3 minus 3 plus b into 3 minus 2. I hope that's correct. Yep. So, yes, 5 into 2, then minus 3. This is minus 3. 5 into 3, minus 3. And then we have 3 minus 3, 3 minus 2. So this is correct. So this is 15. 15 minus 3 is going to give me 12. And this is a into 0 plus, of course, b into 1. So this is going to give me 0, right? Plus b is equals to 12. And that tells us something, that b now is actually equals to 12. So I can go back and then write my function as, say, 5x, right? 5x minus 3, 5x minus 3 over x minus 2, x minus 3, right? Equals, a now is 7. So that is 7 over x minus 2, then plus b is 12 over x minus 3. So, of course, we know that this expansion, this is the same thing as this, over x squared minus 5x plus 6. This is actually equals to this. And that is interesting. Now, it means if I apply integral here, dx, I can apply integral to all of these dx. But we know that integration, in the integration, right, integral sign is linear, right? So it follows the principle of linearity. So that means I can easily say this is integral of 7 over x minus 2 dx plus integral of 12 over x minus 3 dx by the principle of linearity. Now, 7 and 12 are constant, so I can easily bring them out such that I'm going to be having 7 integral of 1 over x minus 2 dx plus 12 integral of 1 over x minus 3 dx. So how do we know what the integral of 1 over x minus 2 will be and that of 1 over x minus 3 will be? So this is what you do. You go back to, right, a particular integral that we know, that we are aware of. So the integral is this. I'm going to write it just at the side. If you have the integral of f prime of x over f of x dx, this is going to give you ln of f of x plus c. So that is, if I differentiate my denominator and I'm getting my numerator, I'm going to take the ln of the denominator, right? The natural logarithm of the denominator. So this gives us 7. If I differentiate x minus 2, I'm going to get 1. So ln x minus 2 plus 12. The same thing to this, if I differentiate x minus 3, I'm going to get 1. So this will be ln x minus 3. And since we are working on an indefinite integral, I'm going to add my integration constant plus c. And this is the solution to our integral. And that's it. I hope you've learned something new in this video. If you have, please drop in the comment section. If you haven't, and it's just a method that you're familiar with, I'll still love to hear from you. I hope to see you on the next one. Thank you.